Another way to classify matter is by looking at what composes the matter. Is it composed of different kinds of particles? Are all the particles the same? Are the particles atoms or are they molecules? So two broad categories are pure substance and mixture. In a pure substance, we have only one type of atom or molecule. So here's a fountain. The water is a pure substance. All the particles in the water are water molecules. They are all the same. That's a pure substance. In a mixture, you have two or more kinds of atoms or molecules. And those are combined in variable proportions. So if you take a glass of water and you put a little salt into it, now you have the salt particles and the water molecules. You have two different kinds of particles. So that makes it a mixture. And you've got a little salt, or you could put in a bunch more salt. You can change the relative amounts of those types of particles. So here's the whole thing, sort of a flow chart. So we take matter, we can break it into pure substances and mixtures. And then we can further subdivide pure substances into those that are elements and those that are compounds. And mixtures can be divided into homogeneous mixtures or heterogeneous mixtures. So that's the broad picture of what we're talking about. So an element is defined as a pure substance that cannot be broken down into simpler substances. No chemical transformation can decompose an element into simpler substances. So you could heat this, you could smash it, you could do anything short of a nuclear reaction, and you would not be able to change what that substance is. So the known elements are listed in the periodic table. There's one on the inside front cover of your book in a table form, and well, in the new version of the book, this may be different. I don't know what they've got on the front and the back. In the classroom here, we have a periodic table on the wall. Those are all the known elements. A compound is a pure substance that's composed of two or more elements. So you take those two elements like hydrogen and oxygen to make water, and you combine them in a fixed, definite proportion. So water has 2 hydrogen atoms to 1 oxygen atom. Always. It's always the same. There's no variation. It's just always the same. It is a combination of 2 elements. It could be broken down into simpler substances. You can actually do that using a 9-volt battery. Put a 9-volt battery into a glass of tap water, and give it a minute, and you'll start to see little bubbles form. Go ahead and try that at home if you like. What's happening is the electric current passing from one battery terminal to the other decomposes the water into hydrogen and oxygen, which are elements. So water is a compound. It's a pure substance because all the particles in the water are the same, but those molecules can be broken down into simpler substances. So it's not an element. Compounds are much more common than pure elements. If you go out, hike out in the woods or up in the Rocky Hills or anything, and you're looking for elements, elements are pretty hard to find because they tend to react with other elements and form compounds. Most of the stuff that we see around us is actually a compound or a mixture, not an element. The difference between a compound and a mixture is that a mixture is just 2 different things mixed together. It's not actually unified chemically. So you've got different kinds of particles and they're just jumbled together. In a compound, they're like welded together in a particular arrangement. The relative amounts don't change. In a mixture, you can have a mixture of oxygen and hydrogen. It's actually quite explosive. You could have a little bit of oxygen and a lot of hydrogen, or vice versa. But in water, it's always 2 hydrogen atoms to 1 oxygen atom. So the proportions can vary in a mixture. Mixtures can be separated using a physical process whereas compounds require some sort of a chemical reaction to separate them into elements. So here we have an illustration of mixtures. The air is a mixture. In the air we have oxygen molecules and nitrogen molecules. And the proportion of them can vary. In the water, in the ocean, that is salt water, and it's predominantly water and salt ions. Sodium ions, the little purple ones here, and chloride ions. And there are other salts in there as well. But it's a mixture. So you think about a river flowing to the ocean. So the water in the river does not have salt in it, and the water in the ocean does have salt. And what happens between where the river is entering the ocean? Like up near Sacramento, they've got the delta, right? And there's this mixture where they sort of come together, and it starts out as pure water with no salt, and as you get closer and closer to the ocean, the salt content increases. It's a mixture. The ratio can vary. Any questions? So mixtures can be divided into two categories, homogeneous and heterogeneous. We use a lot of big words in science. We don't do that to be difficult. We use a lot of prefixes and suffixes. So here these two prefixes, homo means the same. The two things are the same. Heterogeneous means two things that are different, right? So a homogeneous mixture is the same throughout. It has the same composition. Anybody think of an example of a homogeneous mixture? Tea. So in tea, there's obviously water, but there are also things that come from brewing the tea. There are substances that give the tea color and flavor. There's probably caffeine. It's a mixture, but it's homogeneous. You look at a cup of tea, and it's the same, it tastes the same at the top as it does at the bottom. You can make it stronger or weaker depending on how long you let the tea bag brew. It's a homogeneous mixture. Heterogeneous mixture has a composition that's non-uniform. You can see that there's two different parts to it. It might be lumpy or have layers. Can anybody think of an example of a heterogeneous mixture? Oil and water. So, like an oil and vinegar salad dressing. Vinegar is water-based, and the oil is like olive oil or something. So you've got the oil and vinegar salad dressing or an Italian dressing with seasoning in there as well. And you shake it all up, and it kind of mixes together, and then you set the bottle down, and what happens? It separates. The oil comes to the top, and the vinegar part goes to the bottom. As two different parts, it's not the same throughout. So that's heterogeneous. Another example, if we're talking about soup. Okay, so chicken noodle soup, would that be homogeneous or heterogeneous? Heterogeneous, because it's got different parts, right? There's little chunks of chicken and noodles, and then there's the broth. What about cream of tomato soup? That'd be more homogeneous, right? Because you take all the stuff to make the soup and you put it in the blender and you blend it all up so it's the same all the way through. So you've ever looked at the milk carton, it says homogenized milk. Raw milk, if you let it sit, the cream will rise to the top because it's fat, and the skim milk, the non-fat part, will sit at the bottom. Well, people don't like that, right? They want their milk to be the same. So it goes through a process called homogenization, which causes it to be homogeneous. So let's classify matter. Here we're asked to classify each of these as a pure substance or a mixture. And then if it's a pure substance, is it an element or a compound? If it's a mixture, is it homogeneous or heterogeneous? So the mercury in a thermometer. Well, first of all, think about what it looks like. Does it look lumpy or layered? No, it looks like liquid silver, right? So it's obviously very uniform. How do we figure out if it's an element or a compound? If it only has one kind of atom in it, then it's an element. On the periodic table, which we may not be very familiar with yet, there's an element named mercury. So if you can find the name of whatever you're looking at on the periodic table, it's going to be an element. So mercury is an element. Well, I kind of got that backwards. So we decided it's an element. Pure substance, we were supposed to do pure substance or mixture first. I got sidetracked. I like mercury, it's cool stuff. So mercury is a pure substance. We'll call it PS. How about exhaled air? Pure substance or mixture? Mixture. Is that a heterogeneous mixture or a homogeneous mixture? We're talking about normal exhaled air. That'd be homogeneous. Chicken noodle soup. I already used that example. Mixture or pure substance? Mixture. Homogeneous or heterogeneous? Heterogeneous. You can see there's different parts. Another example would be like macaroni and cheese. How about sugar? Sugar is a pure substance. Is it an element or a compound? It's a compound. Now, depending on your experience in science and chemistry, that may or may not be readily apparent to you. But if you look through the list of elements, you won't find sugar. If you think about what sugar looks like, it's very uniform, isn't it? All the little sugar crystals look the same. They're all white and uniform. So that's a big clue that it's a pure substance. And since we can't find it on the periodic table, we should at least guess that it's a compound rather than an element. Any questions? Another thing about sugar is if you heat sugar, you can decompose it into other things, right? Whereas with an element, you can't decompose it, break it into simpler substances. So this is just a summary of classifying matter according to composition. So it can be a pure substance or a mixture. Then pure substances can either be elements or compounds. Mixtures can be homogeneous or heterogeneous. Mixtures can be composed of, you could have two elements, you could have two compounds, you could have one element and one compound, you could have 532 compounds in your mixture, any combination is possible.